very good day to all of you present. Today I'm going to cover the topic types of chromatography. But first, let's see what chromatography is. Chromatography is an important biophysical technique that enables the separation, identification, and purification of the components of a mixture for qualitative and quantitative analysis. Chromatography in general is based on the principle components of a mixture that are separated when the mixture added to the mobile phase is moved through a stationary phase, which is mostly a solid surface, resulting in some components of the mixture being attached to the stationary phase. At the same time, the rest is passed along with the mobile phase. Now, what is the stationary and mobile phase? The stationary phase is a phase that is either a solid or liquid particle attached to a glass or a metal surface on which the components of the mixture is to be separated and absorbed selectively. The mobile phase in chromatography is the phase that is either liquid or gas that is passed through a chromatographic system where the components of the mixture are separated at different rates by absorbing them to the stationary phase. Based on the principle involved, chromatography is classified into different categories. Two of these are absorption chromatography and partition chromatography. Absorption chromatography. In the process of absorption chromatography, different compounds are absorbed on the absorbent to different degrees based on the absorptivity of the component. Here, a mobile phase is made to move over a stationary phase, thus carrying the components with higher absorptivity to a lower distance than that with the lower absorptivity. Following are the two main types of chromatographic techniques based on the principle of differential absorption: column chromatography and thin layer chromatography. Column chromatography. The technique in which the solutes of a solution are entitled to travel down a column where the individual components are absorbed by the stationary phase. Based on the affinity towards the absorbent, the components take positions on the column. The most strongly absorbed components is seen at the top of the column. Thin layer chromatography. It is a chromatography technique where the mobile phase moves over an absorbent. The absorbent is a thin layer which is applied to a solid support for the separation of components. The separation takes place through differential migration, which occurs when the solvent moves along the powder spread on the glass plates. Partition chromatography. In this process, a continuous differential partitioning of the components of a mixture into a stationary phase and mobile phase takes place. The example of partition chromatography can be seen in paper chromatography. In this process, chromatography paper is used as a stationary phase which is suspended in a mixture of solvents that act as a mobile phase. Here, we put a spot at the base of the chromatographic paper with the mixture to be separated, and as the solvent rises up this paper, the components are carried to different degrees depending upon their retention on the paper. The components are thus separated at different heights. Thank you.
Chromatography is widely used for different purposes in a variety of industries, mainly in food and forensics. In food industry, chromatography can be used in flavor studies and to detect spoilage in foods. Determining the number of organic acids in food provide key information about the quality of foods. Column chromatography is used to detect and quantify spoilage indicators such as pyruvic acid in milk. Pyruvic acid content is a measure of psychotropic bacteria present in milk. Additive detection. Additives are added to foods to enhance their flavors or to give them a visual appeal. For example, the presence of added malic acid in apple juice is more difficult to detect because apple juice naturally contains malic acid. However, synthetic malic acid contains fumaric acid as a containment, and hence its level in apple juice sample is an indicator of the commercial malic acid. Chromatography has been successfully used to detect and quantify fumaric acid in apple juice. In forensics, gas chromatography is used to test evidence such as blood or hair from a crime scene. This allows investigators to understand the crime better and to develop theories on what exactly happened and where the victim has been earlier, based on the material found. Gas chromatography has also been widely used in forensic pathology to identify the type of compounds and fluids present in the human body post death. This testing can help detect the presence of alcohol or drugs or poisonous substances in the body at the time of death, thus assisting in determining the possible motive and cause of death. Thus, it's very clear that chromatography has a wide range of applications.
So, in conclusion, chromatography is a widely used laboratory procedure for the separation of the constituents of chemical. It is a procedure which is used for the creation of vaccines, for drug and food testing, and also for forensic purposes. It's a procedure which is considered essential to the scientific community now, and it has led to the discovery of many new tools for the human race. I hope you enjoy the presentation and that you actually learned something from it. Thanks.